Hello, guys. Today we are going to see the second article from the Max Planck Society Yearbook 2021, Biology and Medicine section. So, article is computers are learning how to be curious. Although computers game are made for entertainment purposes, my team and I are using them for behavioral research. This is not only opening up new approaches in the field of psychology research. Our research results are also helping to improve artificial intelligence algorithms. Curiosity is one of the key characteristics of the human species and is especially evident in children. It is curiosity that prompts the eponymous heroine in Alice in Wonderland to follow a white rabbit down the hole, which leads to a dreamlike magical world thanks to her childlike sense of wonder and her love for exploration. Alice learns to assert herself in this new world and comes up with ever new solutions to a series of conundrums. Experimental psychologists usually employ quite simplistic scenarios to study the root causes of human behavior, such as curiosity. For example, to study the principles of intelligent action, test subjects are asked to repeatedly choose between two options or to compare the length of two lines. Simple experimental setups such as these do not reflect the complexity of the real world. In terms of dealing with complexity, machine learning theories are already far superior to human learning theories. The capabilities of artificial intelligence algorithms have also increased dramatically during the past decade. One of the main reasons why computer capabilities have increased to such an extent in such a short period of time is that the focus has shifted. Increasingly, computers have been optimized to cope with multiple environments and to learn more complex behaviors. The results are impressive. Computers running artificial intelligence algorithms have even beaten human world champions in Go, a centuries old board game, and are able to solve difficult mathematical problems. The goal of my research group is to make a similar transition in our understanding of how humans learn. We use complex computer and video game environments to study human behavior in realistic environments. In particular, we focus on those behaviors in which humans still outperform the best computer algorithms, such as creative processes. Playing with the elements, one of the games we use is a Little Alchemy, which can be played for free online at https littlealchemy.com/. Players start with four simple elements: earth, water, air, and fire, any two of which can be combined on a virtual screen to create a new one. For example, combining water and fire produces the new element steam. A total of 720 elements can be created from simple ones such as clay and grass to more complex ones such as humans and ice cream for astronauts. The remarkable thing is that although there are no prizes for creating elements, thousands of people play the game every day. Why do they so? And how can their behavior best be described in scientific terms? In a collaboration with the game's inventor, we studied and mathematically modeled the behavior of about 30,000 players in more detail and found that players try to create elements from which they can create as many other elements as possible. This kind of curiosity is known as aptitude. Our findings lead us to conclude that people act like this because they enjoy being able to create more and more new elements while simultaneously learning more and more about the game. Our current goal is to program the characteristics that typify human curiosity into an algorithm, AI algorithm. We use a more complex online game to explore how large groups of people discover one another and interact creatively. Players form groups and develop new technologies in the game. 1 hour, 1 life. HTTP colon slash 1hour1life.com. Hereby, each player is born into a random family and scenario and aged by a year every minute. Family members explore their surroundings together, and just as in little alchemy can combine existing elements to form new ones, even complex objects such as cars or aeroplanes can be created from stones and sticks, whereby each player only makes a mirror contribution to the development of the entire family over several generations. At the time of writing, the oldest family line extends over 800 generations. Success in the game. We analyzed the behavior of approximately 30,000 players in 6,300 families to gain an understanding of what distinguishes successful, highly innovative groups from less successful ones, and found that successful groups share two primary characteristics. First, people are able to join in an efficient and purposeful manner, that is, in essence, they can quickly adopt roles for which there is a current demand. Second, all members in these groups share information frequently in mathematical terms. Collective curiosity, which can be thought of as a directed research process, can be plotted on a graph that encompasses all the elements in play. We are currently attempting to develop algorithms that are capable of playing this game as well as humans, or can at least collaborate with them. We believe that the complexity of games will enable us to construct more realistic models of human behavior. If we can discover the assumptions that players tend to make in advance, then it should be possible to program them into machine learning algorithms to make them more efficient. Presumably, computer games could also be used to investigate the limits of human learning. Our research could bring about a paradigm shift in psychology. In the future, methodologies from the fields of data science and machine learning could enable the study of theories in cognitive and learning psychology, like Alice in Wonderland and our playful test subjects. We will have to stay curious to effectively combine both disciplines. Thank you. Not next, we will in next video we'll see the surprising history of our oral bacteria. So we're gonna read about that in the next video. Stay tuned for next video. Thank you guys.